The optoelectronics group of Vishay Semiconductor offers a complete portfolio of ambient light sensors with analog output. This 7-slide presentation describes the key features of this portfolio. When it gets dark and the front porch and street light automatically turn on, they are using an ambient light sensor. When your car lights turn on when entering a tunnel or at dusk, it's using an ambient light sensor. And when the power to the backlight on your touchpad phone or notebook PC automatically adjusts, it's using an ambient light sensor. By measuring and responding to ambient light, these sensors help conserve battery power, optimize visibility, and provide extra safety by eliminating the need for manual adjustments, making life safer and simpler. An ambient light sensor must distinguish between many different wavelengths of light. For example, sunlight contains a broad range of UV, visible, and infrared light, while incandescent and fluorescent lights contain visible and infrared light. Using a standard silicon photodiode as an ambient light sensor won't work because it responds or is sensitive to both visible and infrared light. Using an ambient light sensor, which has the same sensitivity to visible light as our eyes, will ensure optimum device performance. For example, the TEMT 6200 FX01 responds to light just like our eyes. Let's take a look at a test showing how Vishay's ambient light sensors perform versus the leading competition.
Light source, a halogen lamp with a high portion of infrared emission. Second, a white LED light source with basically no infrared portion in its emission spectrum. Furthermore, we have 3 different positions for the sensor components. In the first position is a standard technology-based phototransistor. In the second position is our competitor's ambient light phototransistor, and in the third position, Vishay's TEMT 6200 FX01. So we set the brightness level to a typical office environment, let's say at 1500 lux. We first take the reading with the light source of the halogen lamp and record the measurements. Now we switch the light sources and go over to the white LED. We still have 1500 lux, but now coming from the white LED light source. We again
As we saw in the video, an ambient light sensor must respond to visible light, but be unresponsive to UV and infrared light. One way to compare the performance of Vishay's ambient light sensors versus standard silicon photodetectors and the competitor sensor is to calculate the ratio of response to halogen versus LED light. The closer to 1, the better. The standard silicon photodetector has a ratio of 4.71. The competitor's part, the SFH 3710, is at 1.45. Vishay has the best performance with a ratio of 1.2. Vishay's ambient light sensors are responsive to visible light and unresponsive to UV and infrared light. It's just what we want in a reliable ambient light sensor. Vishay offers phototransistor and photodiode-based ambient light sensors. The phototransistor portfolio includes leaded and surface mount devices. Note that all of these sensors have a peak sensitivity from 550 to 570 nanometers, which is nearly equivalent to our eye's peak sensitivity. Part numbers with an F contain an infrared filtering epoxy to further improve the ambient light sensing performance. Part numbers with an X01 are qualified to the AEC Q101 standard and support operating temperatures from minus 40 degrees C to 110 degrees C. The photodiode portfolio also includes leaded and surface mount devices. The leaded device, the BPW21R, is packaged in a hermetically sealed TO5 metal package. It is designed to operate in particularly hostile environments. Again, all of these sensors have a peak sensitivity from 540 to 565 nanometers, which matches our eye's peak sensitivity. Thank you for taking the time to learn about Vishay's ambient light sensors and for considering them for your next application. If you have any questions, please send an email to detectortechsupport@vishay.com. For more information or to order free samples, visit us at www.vishay.com.